Hey,
Who you a fool for this? Who you a fool for this?
When adding a solute such as table salt into a solvent like water, there are different levels of concentration that we can assign to this solution. It can either be unsaturated, saturated, or supersaturated.
super sus-saturated.
Shut the fuck up. Okay, so first what we have is water with no salt in it. So what I'm going to do is I'm just going to add a tiny amount of solute to it. So now I'm going to mix it, and we can see that the table salt completely dissolves in it. This means that I could probably add a little bit more solute to it and the salt will dissolve. At this point we could say the solution is unsaturated. Now I'm going to try and get as close to the saturation point as I can. I'm going to add a good amount of salt. And I'm going to mix it. And we can see that basically there's a tiny left amount of solute at the bottom that did not dissolve. This means that the solution is saturated. This means that if I add more salt to the solution, we will see the salt start piling up because there's no more ion-dipole bonds left to make. Next, we can make a supersaturated solution. What this means is that we add solute to the solution, and when it precipitates to the bottom, we can actually get it to dissolve by adding heat or increasing the pressure. So I'll actually show this. Got a good amount. So we can see that at the bottom there is some salt left. So I'm gonna throw this in the microwave and we're gonna see if it all dissolves.
Hey. Oh Lord, Jesse made another one.
We gon' front it dirty, front it wild.
Alright, I just put this solution in the microwave for 30 seconds and now I'm going to stir it. And what you can see is that all of the salt that was on the bottom, that was stuck to the bottom, you basically can't see it anymore. This means that it dissolved in the water. And now that all of that precipitate has dissolved, we can call this solution supersaturated. One thing you might see on a chemistry exam is a saturation curve, or a solubility curve. What we have here is the temperature of water versus the solubility of potassium nitrate. We can see that at low temperatures, there is a low solubility. For example, at 0 degrees Celsius, only about 15 grams of potassium nitrate are dissolved in 100 grams of water. However, as we increase the temperature, we can dissolve more and more potassium nitrate. We can look at 3 different dots on this graph to learn about the solution. At this red dot, we can see that it is above the curve. This means there is more solute than the amount of solute needed to create a saturated solution. This means the solution is supersaturated. If you saw the solution in your hands, you could see precipitate forming, or precipitate and like salt forming at the bottom. In this brown curve, in this brown dot, we can see that the dot is below the solubility curve. This means that you can add more potassium nitrate and no precipitate will form. This is a unsaturated solution. The final dot is this green dot. This dot is right on the curve, meaning that it is saturated. That means if you added just slightly more potassium nitrate, precipitate will start forming.
Yes, teacher.